Gibson.
This is the kind of foam we're talking about, and it's hard to believe that a piece of this stuff weighing about 2 pounds, 20 inches long, could actually cause the breakup of an 89-ton spacecraft. But after months of analysis, investigators believe that's exactly what happened. The foam would have hit the leading edge of the shuttle's left wing in about this area, and it's this reconstructed wing, with actual pieces of the shuttle suspended behind plastic, that led investigators to their theory of what happened to Columbia in its final moments. As the shuttle approached the California coast at more than 23 times the speed of sound, its re-entry was normal until 8:52 a.m. Superheated gas or plasma entered the breach in the shuttle's left wing. The wing began to melt from the inside out. The crew had no idea that small pieces of debris were falling away from the shuttle. Over a 4-minute period, more than 160 measurements failed as the plasma burned through the left wing and wheel well like a runaway fire hose. The miracle may have been that Columbia kept flying normally for so long. But by 9 a.m., America's longest flying shuttle was disintegrating over Texas.
The men and women of the Columbia had journeyed more than 6 million miles and were minutes away from arrival and reunion. Today we remember not only one moment of tragedy, but 7 lives of great purpose and achievement.
As the world grieved along with the astronauts' families, a blue ribbon board, the top accident investigators in the country, assembled in Houston. Their first job? To recover the evidence. In the end, 84,000 pieces of twisted metal, glass, and plastic spread out over more than 250 miles.
It's got numbers on it.
Over 15,000 people joined the biggest ground search ever. Each find was precious. An astronaut's helmet, a mission patch, and most crucial of all, the shuttle's intact flight data recorder. That data recorder, plus forensic clues from the debris, pointed investigators for the first time to the wing's leading edge as the spot where the foam hit. Retired Admiral Harold Gaiman heads up the investigative board.
We literally have dozens and dozens of pieces of evidence all pointing in the same direction, and we have no evidence which points in any other direction. So to us, that's pretty compelling.
The board kept enhancing the video of the foam strike, and with each clearer image, the hit looked more ominous.
There's nothing terribly mysterious about the fact that a piece of foam this big going 700 feet per second can do a lot of damage to whatever it hits.
Retired NASA engineer Robert Thompson is one of the space shuttle's original architects.
That's equivalent to taking a 200-pound weight 100 feet in the air and dropping it on you. It hurts.
But the case of the falling foam, no matter how convincing, was still circumstantial. So the board conducted a series of tests, one as recently as today, firing foam pieces the same size that broke off Columbia's fuel tank into the leading edge of wing panels from another shuttle.
2, 1, 0.
We have found the smoking gun. You know, it was a visceral reaction. You know, it was shortly followed by, oh my God.
The test confirmed the foam struck with enough force to open a hole in the wing panel. The panel made of a substance called reinforced carbon-carbon, or RCC.
I think foam hitting the wing leading edge of the orbiter at 500 miles an hour is the direct cause.
Investigators were stunned to learn that foam was breaking off the fuel tank and hitting the orbiter on every single shuttle flight, every one. In fact, just 3 months before Columbia, there had been a close call. A large chunk of foam narrowly missed hitting the shuttle Atlantis after breaking off the same exact part of the fuel tank. Bill Reedy is the associate administrator at NASA.
We had the engineers go off and do the analysis on that. They arrived at the conclusion that there was no way for foam to get from this area on the tank to this area and strike the orbiter.
But that analysis turned out to be straight out wrong.
It may turn out in the end that it was in error.
Actually, NASA had been given repeated warnings. This internal NASA document, written 3 years ago, showing that foam was a high-risk safety concern. And this report, commissioned by NASA in 1990, saying that the tiles and protective panels on the shuttle could fail because of hits from debris, in particular pieces of insulation or foam from the external tank.
They had become accustomed to foam coming off and hitting the thermal protection system. It had happened on every flight.
This was not deemed to be abnormal and so therefore an acceptable risk.
In other words, we got the shuttle back before with foam damage to the tiles or to the leading edge, so let's hope we can do it again.
The depth and the scope of the damage that had been assessed was really quite insignificant in the judgment of the engineering analysis team. Now, again, that may prove to be a judgment call we call into question here, but it wasn't a hope. Hope is not a management method I'm familiar with at all, okay?
The foam had been defined early on as not a threat to flight safety, and even though the amount of damage increased, they continued to define it that way.
Diane Vaughn is a consultant to the investigative board. She spent 10 years studying NASA's culture after the Challenger disaster. She says the same thing happened back then, only instead of foam, it was O-rings. And once again with Columbia, NASA didn't see the danger until it was too late.
I don't believe it's this foam. It's got to be something else that we don't know about yet.
Ron Dittemore said at the time, we analyzed it and we understood it, we were comfortable with that. And comfortable is not really what you want to be. Comfortable is what they became with Challenger.
But most disturbing of all was what the board concluded about NASA's overall safety organization, that budget cuts and other factors had left it dangerously inadequate. You said they don't have people, they don't have money, they don't have engineering, they don't have expertise, and they don't have analysis.
That's correct.
That's pretty damning.
That's right.
And you said, when you really look at it closely, there's no there.
On paper, it looks great. And there is a name and a telephone number in the desk to do everything that needs to be done in the safety organization. But they are very, very shallow.
NASA says they have more than 1,700 people devoted to safety, and that whenever they find a problem, they fix it.
In my experience, having gotten to NASA after the Challenger and been in the first astronaut class selected, I have never seen any evidence of complacency. Quite the opposite.
But the investigative board will insist that NASA fundamentally reassess how safety concerns are communicated. There is no excuse, investigators say, for the engineers' warnings to not have reached top shuttle managers.
The professional system by which professional engineers express legitimate safety concerns up the chain of command, that system broke.
It wasn't just the foam debris hit, if that's what it turns out to be, that took Columbia out of the sky. It was also a failure of the organizational system. It's a tragedy because people at NASA, like Rodney Rocha, all of them are going to spend their lives what-ifing. What if I had done this? What if I had done this? Not seeing themselves as part of an organizational system that failed.
NASA says it will implement everything the board recommends and go further. Last week, Linda Ham, who chaired that critical meeting where a decision was made that there was no safety of flight issue from the foam hit, was reassigned, along with several other top shuttle managers. NASA emphasizes that they're not blaming any particular individual and says that it's easier to criticize after the fact than to make real-time decisions. Best guess. When do you fly again?
The answer is as soon as we can do so safely. We've got to find first what the problem was, and we're really close. It's getting very, very close.
But can the shuttle be made fail-safe? After all, you're harnessing 23 times the power of the Hoover Dam and flying 9 times faster than a rifle bullet.
We believe that the shuttle can be made reasonably safe to fly. It'll never be safe.
If you don't fail, you haven't pushed it to the limit.
For John Clark, these plasma-scarred mementos from his wife Laurel, recovered in the wreckage, aren't a sign of failure, but a badge of honor.
I'm glad she got to do what she loved to do. Was it worth a life? The loss is huge for us. My son not having a mom, me not having a wife. I think in reality, though, to be able to live your dream is worth a life. And she's a source of inspiration to our son forever and ever. He will have this sense of pride that my mom gave her all, gave her life in the pursuit of a dream that others could benefit from that. It's a precious thing.
One critical question